So again, this is limits of functions, graphical approach. So calculus relies on the notion of limits. Perhaps it is the reason why it is sometimes defined as the study of limits. So that is limit of a function and limit of an area. So I'm going to introduce to you a more detailed description of the concept of limit, and we are going to begin with a visual notion. That is concrete way of understanding limit. Okay? So limits of a function, graphical approach. In pre-calculus, we're given a value of x, and this is in the domain of f, no? Where f is a function, and we are interested with the function value. Okay? So we want to know the value of f at x equals a. Normally, that's what's the concern of pre-calculus. Just the function value of the of f at x equals a. In calculus, it's different, you know. In calculus, so we're given values of x, okay? And so we're given values of x, and these values of x are in the domain of f, where our f is the functional. And this is what we are interested. So values of x approaching, let's say, approaching a, okay? We are interested with values of f of x values that f of x approach. So values of that f of x approaches. So this is what we are interested. As the values of x gets closer or approaching or approaches, as the values of x approach, let's say a not necessarily in the domain of f. Okay, so again, in pre-calculus, normally we're given x value, which is in the domain of f. We are interested in determining the value of the function at a. But in calculus, given values of x in the domain of f, we are interested in the values that f of x approaches as the values of x approach a, where a not necessarily in the domain of f. Graphically, so in this case, let's say a is in the domain of f, and let's say the graph of f is given by this. And this is our a, for instance. And this is the point corresponding to a. Okay? As x approaches a from the left and from the right, so meaning as I travel along the curve from the left of this point towards this point, and also possible I will travel along this curve approaching this point, we want to know where the values of f of x approach or tend to go. No? So this is where we are interested. What is this value approached by f of x? No? As we travel along the curve going to this point, either from the left or from the right. It is also possible that a is not in the domain of f. So this is x, this is y. And let's say this is a. Again, a here is not in the domain of f. And let's say this is the graph. And this time, a is not in the domain of the function. Okay? So meaning it's a hole there. Now, as I travel along the curve approaching a, either from the left or from the right, where does f of x tend to go? Okay? So this is what we are interested. So whether it is in the domain of f, that a, or not in the domain, can we attain this value? Okay, so that's our goal. And actually, if we can reach or if we can attain a value here, we call that limit of a function at a, or limit of f of x as x approaches a. Okay? So, in other words, we want to know how f behaves near or close to x equals a. So, ang goal natin to know the behavior of f of x near or close to x equals a. Okay, guys? Do you have any question with this, guys? So let us illustrate this by the following graphs.
Wait, so yung behavior ng f of x, yung hahanapin is kung
Yes,
saan
that's what we
siya.
want to know. To know how f behaves near or or close to x equals a. Like for instance, let's us consider this graph. Let's say I have this graph. So this is a linear function. And I am interested with this point, meaning I am interested with this value of x here, and let's say that is a, corresponding here. And it so happens that at a, this function is defined, right? So here, f of a is defined. And let's say that a of mine is specifically 2. Let's say this is 2. And let's say, align with this point along the y-axis. So let's say this is 2 also. Okay, guys? Yeah. So let us investigate the behavior of f at x equals 2. So consider values of x approaching this number 2. So meaning that is the value of x. So approaching meaning going to 2, but not equal to 2, just going. So when you say are approaching to 2, that is arbitrarily close to 2, arbitrarily close to 2, but not equal to 2. Okay? So if I'm going to travel along this line from the left of 2, but approaching to this point, travel, travel, travel. So where does the value of the function go to or tend to go? So from here, it will tend to go to this number. What number does the function tend to go? It tends to go to this number 2, no? Okay? So that behavior, I can write f of x. So this is my y equals f of x. As f of x, f of x tends to go to 2 as what? As x approaches 2 from the left. So this means as x approaches 2 from the left. So verbally, f of x approaches what? Approaches 2 as x approaches what? Approaches 2 from the left. And mathematically, that is how we write it. From the left. Okay? So again, where does f of x tend to go? It tends to go to 2 as x approaches 2 from the left. Or in a more compact way, this f of x approaching 2 as x approaches positive 2 we write this in a more compact form, limit of f of x as x approaches to is equal to 2. Okay? So that's how we write that behavior. So coming from what? From the left. We put negative as superscript of 2 to mean approaching 2 from the left. What about the behavior of the function? As I travel along the line, approaching to this point, but from the right. So I will travel approaching to this point, meaning I will approach 2, x equals 2, I will approach coming from the right. So where does the function tend to go? So meaning it will be coming from here, no? It tends to go to what? What do you think? It goes to this number, no? As I travel from the right, going to this point, going, as I am very, very close to this point. So the function value is very, very close to what? To 2, no? So we call that the value approached by the function. And if there is a value approached by the function, we call that the limit. Okay? So we write that behavior f of x approaches to as x approaches to from the right. And equivalently, we write that limit of f of x as x approaches to from the right with plus sa above the 2, superscript. And that is equal to 2. Okay, guys? Collectively, yan, this 2, yan, can be written, these two behaviors, in a more compact form, limit, or in just one notation, limit of f of x as x approaches to is equal to 2. So meaning, if you have the same behavior coming from the left of 2 and coming from the right of 2, you get the same values. So we can write it limit of f of x as x approaches 2, and that is equal to 2. So no need to write plus or minus here. So and we say that the limit of f of x as x approaches to exists, and it is equal to 2. Okay? So that's how function behaves near x equals 2. As x gets closer and closer to 2, f of x is attaining a limiting value. And that is called the limit of the function as x approaches that number a. And that a is equal to 2, and the limit is equal to 2 also. It so happens. Okay, guys? Let's have another one. So, but you notice here, notice the function value is equal to the limit in this case. But let's see if that is always the case in the next example. Okay? Let's see. Let's say I have another graph. I want you to understand limit in a concrete way, what it means by limit of a function. What is happening, no? So let's say I have this graph. Do you have any question, guys?
None po for me.
So let's say I have same graph, except that, almost same graph, except that it has a hole here, and then the graph continues after that. Okay, and assume that this is also a straight line. So meaning it is a linear function. No? So that is why my y equals f of x. It is a linear function because it is a straight line. Now let's say this is my a. Let's say this is 2, and assume that this is, let's say, 1, no? let us just assume, no, that this is 1 and this is 2. Okay, align with that. But remember, this is a whole. The function is undefined at this point, no, or at x equals 2. So here we say that what? F of 2 is what? Is undefined in this case. So it means 2 is not in the domain of f, unlike in the first case. But can we still attain a limiting value for the function as we get closer and closer to 2? So let's see. I'm going to approach 2 coming from the left. So as x approaches 2 coming from the left, where does my function tend to go? So again, I will travel along the curve, travel. So until I am very, very close to this hole. So where do you think the function tends to go? It tends to go to what value? As I travel very, very close to 2, but from the left of 2. Guys, f of x approaches what? Or tends to go to what value? What do you think?
1 po.
1, no? So f of x approaches 1 as x approaches 2 from the left. So, or equivalently, we write limit of f of x as x approaches what? 2 from the left, and that is equal to 1 in this case, no? Let's check the behavior from the right, no? Again, I will approach 2. So coming from the right, so I will travel along the line, travel. As I am very, very close now to this hole. So where does my f of x tend to go? It tends to go to what? It tends to go to 1 also. Since from the left and from the right of 2, they have the same behavior when x is very, very close to 2. But x is not equal to 2, huh? It is just very, very close to 2. So from the right, it is also equal to 1 as x approaches 2 from the right. Since they have the same behavior from the left and from the right of 2, so we can write this in what? In one relationship, no? So we have limit of f of x as x approaches 2 is equal to what? So what is the limit of the function? Guys, it is equal to 1. Okay? So we say that the limit exists, no? Limit exists. Even though the function value is undefined there. Even though f of what? F of 2, it's almost time, is undefined. So see the difference between the function value now, guys, and the limit? Are you seeing the difference, guys? Function value is the actual value of the function, meaning the value of x must be in the domain and there must be a corresponding real value for y. But for the limit, the x that we are considering, let's say at 2, the limit at 2, so we want only your x to be very, very close to 2. Okay? And we want to determine if there is a limiting value approached by what? By the function. So that's the difference, no? So limit is just the value where the function tends to go. While function value, we are looking for the corresponding real value for y or for the function. And it must be what? In the domain. But x equals a not necessarily in the domain of the function if you want limit. as long as you can travel along the curve going to that value, not necessarily that the function is defined there. Is that clear, guys? Guys,
Yes po, sir.
that's the difference between function value. Limit may exist even though the function value is undefined. Okay? So notice that you have the same what? Linear function. If I actually put this as 2, they have the same limiting value, no? Kung nilagay ko sana itong 2. So, but in the first case, f of x is undefined. In the second case, defined. In the second case, it is undefined. Is that clear, guys?
Yes po, sir.
Give me 3 minutes. So let me give me one more. Because, so it's what you call this? Parang the momentum will be cut in case if you will not have this. Then we'll continue next meeting to give you some more a possibility for the limit. Let's say I have this graph, because later we will not be having anymore the graph. We will be finding the limit without the graph anymore, given the function. Let us consider this graph. And then I have a value here, the hole there, and then it goes down there. So this is the graph of my function. This is my y equals f of x. Now, what can you say the function value? Let's say this is 1, and this is 1, and this is 2. What can we say about the function value, guys? At 1. Is it defined, guys?
No po.
It is defined. When x is 1, the function value is equal to 2. It is defined. Am I correct, guys? This is the value. Okay? Is that clear, guys?
Yes po, sir.
Now, let me examine the behavior of the function as I travel along the curve approaching 1 from the left.
Time na po.
Yes, give me 3 minutes. So travel. Oh, what behavior do I get? What is the limit of my f of x as x approaches 1 from the left? What do you think? It goes where? As I travel from the left, it goes to what value?
1 po.
It goes to 1. So limit exists from the left. Okay? What about limit of f of x as x approaches 1 from the right? So this time I will be getting closer to 1, but traveling along the curve from the right. So travel. So I am what? I am approaching what number, guys?
2.
Approaching 2. Do they have the same limiting value?
No.
No. As I travel along the curve coming from the right and coming from the left of 1, I did not get the same value. So we say that limit, we say that limit as x approaches 1 of f of x does not exist. Okay, guys? So that is how it behaves. So the limit of f of x does not exist. Function value is defined, and notice that limit from the left exists. So this exists. This limit exists. Okay? But totality for the behavior of f of x as x approaches 1, so does not exist because we did not come up with the same value, meaning our goal is to come up or to go to what? To tend to go to one value as I travel along the curve coming from the left and coming from the right, approaching a specific value of x. So in this case, function is defined, but the limit does not exist. Although limit from the left, limit from the right, both exist. See the difference, guys? So by next meeting, we will be dealing with more, and we will be trying to find out whether limit exists or does not exist as x approaches a particular value of a, and for other cases. Is that clear, guys?
Yes po, sir.
Okay. So if you have questions later, you reserve that by next discussion. And then after that next meeting also, we will be having numerical approach. So you will be given equations, or in terms of equations this time, and no longer graph. So here, determining the behavior of f of x, that is the limit of a function through graph, because I want you to understand limit in a concrete or in visual form. Okay now? Okay. So that's it for today, guys.
Thank you, Professor.
So if you have questions, you just reserve it by next meeting. You read more so that you can have questions by next meeting, okay?
Okay po.